We can allow Mina applications to really scale to full user base of not just Ethereum, but we can build the same kind of system for other blockchains as well, right? So if we want to tap into Solana users or any other user base from the top 10 or top 100, whatever you want, Mina can support this. And so in this way, Mina is this kind of zk coprocessor, this kind of machine that theoretically multiple blockchains could leverage, and we can build these kinds of interoperable solutions between and many different kind of ecosystems so everybody can play from within the same kind of game or application state without having to natively have to know not only that Mina is being used, but that there are other players from different ecosystems playing the same kind of game as well.
Hello everyone, welcome to Just the Metrics podcast. Today I'm having a conversation with Sebastien Guillemot from zk-Rollups. zk-Rollups is involved in the development of Zeko, a layer 2 zero-knowledge rollup designed specifically for zero-knowledge applications or zk apps. This ecosystem is built on top of Mina protocol, aiming to provide a platform that enables developers to create decentralized applications with programmable privacy. Sebastien is someone with more than half a decade of building experience in the blockchain space. He has experience with building layer 2 solutions on top of protocols like Cardano and Algorand. And in this conversation, we get his perspective on why he is building in the Mina ecosystem and capabilities provided by the solution for the developers who would like to build cool solutions in the Mina ecosystem. So without further ado, let's get into this conversation with Sebastien. Welcome, Sebastien.
Yeah, thanks for having me. So my name is Sebastien. I'm one of the co-founders of Zeko, as well as one of the co-founders of Pima Studios, which is a company building one of the use cases for Zeko. So Zeko is this zk-Rollup project that is targeting the Mina blockchain, and it is an isomorphic zk-Rollup. What does that mean? It means that you're not adding a new virtual machine to the Mina blockchain. We're instead taking the existing smart contract programming language, the existing framework that Mina has as layer 1, and taking that same technology and enabling it to run as a layer 2, which allows this fractal scaling inside the Mina ecosystem.
Before we get into the core topic of Zeko, why do you think that zk-based scalable is the best way to scale a blockchain?
Yeah, it's a good question. So let's imagine you're trying to build an application that needs massive scale. So for example, you have 1 million users per day, something like this. Oftentimes you cannot process every user action on a single machine, right? You need multiple machines that are running independently. And then the results occasionally get merged together into some kind of centralized location that aggregates the results of everything. So an example of this would be YouTube, right? YouTube could not possibly all run on a single machine. Instead, what they have is different data centers, different places across the world. When you're connecting to YouTube, you connect to that website. And then the stuff you do, like the view count, which videos you're interacting with, all that kind of information, occasionally gets sent over to some kind of archive node in a sense that tries to aggregate all the information from all the different users across the world and build a global view of the YouTube network. So you can think of this similar system in the concept of blockchains, right? If you want to have a blockchain scale to millions of users, you can try and build some one single chain that handles everybody. This is borderline impossible. And so what would make a lot of sense is, okay, we have different users interacting on different networks, and then the aggregation of all that information occasionally gets synced up to a single layer 1, single source of truth. This is make the vision of the Ethereum roadmap for the past few years now, which is layer 2 scalability. So there's different layer 2s coming out, OP stack, Arbiter, all these different solutions. And although they have different users, different data, all data from all these different layer 2s, at the end of the day, get aggregated into the core Ethereum layer 1. Now, one of the big topics on this discussion is, okay, how do we easily do cross layer 2 bridging, or how do we easily aggregate all this information together? And optimistic rollups make this a bit tricky because you have to actively monitor those chains to know whether or not the state is correct. So have you ever heard of like the withdrawal period, the 1 week system, the optimistic, like the word optimistic, or like fraud proofs? These are all related to this concept that even though a layer 2 built with an optimistic rollup system submits to layer 1, it does not mean that data is correct. If tentatively correct, we think it might be correct, but to know if it's really correct, you have to wait until somebody verifies it, reruns the computation, and does not fraud proof it. And this is what causes this 1 week delay period, where if you want to go from a layer 2 to layer 1 with an off the scroll system, you often have to wait a week. Now, in practice, this is not that big of a deal for a lot of use cases because, for example, for Arbitrum, it has enough economic activity that there's people actively monitoring the layer 2 state of Arbitrum. And if you want to go from Arbitrum to Ethereum, somebody can give you the funds in advance. They look at the transaction and say, okay, I don't need to wait a week. I've run Arbitrum myself. I know this is valid. And so I can give you the funds ahead of time. And I know I'll get my money back in a week. And so they can provide this kind of service. And so there's like fast bridges for layer 2 to layer 1 that can bypass this 1 week withdrawal period. And although this kind of works, it's not really ideal if you have something that's app specific, in my opinion. Because if you have something app specific, oftentimes you want to crank up the processing power during times of high volume and then lower the processing power in times of low volume to save money. And this is hard to do with an optimistic rollup system because that means that you're basically the only one who's going to be monitoring this. You're spamming new instances, shutting down new instances. Most likely, it's not that many people that are going to be coming up and monitoring all these different layers as you spin them down. And so within this context, zk-Rollups can help solve this problem. zk-Rollups, if for those who don't know, is a way to basically have a distinct proof of the correctness of the layer 2 state, such that you cannot have invalid state transition posted directly to layer 1, which means there is no kind of 1 week waiting period or these kind of issues. And so if you use this kind of zk-Rollup system for these kinds of large app chains, it solves a lot of the trust issue because it means you can spin up new layer 2s as needed, shut down layer 2s as needed, but people don't need to actively monitor those layer 2s. As long as they can see the proof and verify the proof, which is a distinct proof, a small proof, that's all they really need. And from this kind of perspective, that's why I'm really bullish on zk for scaling apps. And that's why I'm focused on this from like the Pyma engine perspective, which is a Web3 engine we built for games or gamification use cases, but can also definitely be used for DeFi. For example, there's another team called Lumina Dex that's building a private DEX for Go. And to get to your other question, which was why Mina instead of Ethereum, right? Also, Ethereum has a lot of really cool technologies, a lot of really cool projects, and we're building stuff on Ethereum as well. But there is one problem, which is what happens if you have 10 different zk-Rollups for your application to scale to the user count you need. How do you post these to the Ethereum layer 1, right? The current way you would do it is you would usually have these 10 different rollups, post 10 different proofs, and a few minutes later, they post another 10 different proofs, and then a few minutes later, they post another 10 different proofs, right? And now if you want to know the full application state of your system, you need to synchronize the Ethereum layer 1 and then combine all these proofs together on your machine. So although the system of creating a whole bunch of new layer 2s to fractures, is the word I'm looking for, fragment your user base into smaller groups that you can handle with the computational resource. Shard is the word I'm looking for. So you can like shard users based off their geographic location or some other parameters. When you're doing the aggregate verification of the state, you're still stuck doing like aggregating 10 proofs together, aggregating another 10 proofs together, aggregating another 10 proofs together. And that has a computational overhead as well. And so it'd be better if instead you had just these proofs all be aggregated as well. So you do an aggregation over the aggregation. And that's not really possible with Ethereum Layer 1 in its current configuration. Ethereum Layer 1 is not zk verifiable in its current form. And there's no way to generate recursive proofs. And I won't get into details too much about this, otherwise this is going to be a long talk about cryptography. But there's no way to easily have a succinct proof of the Ethereum Layer 1 history in its current configuration. Whereas this is possible for Mina blockchain. And so Mina has this concept of recursive proofs that allow you to take aggregations of aggregations. So you have 10, 10, 10, and you take all those brackets together and you compress it down to another single proof of the aggregation. And so this allows not just easily scaling of users by spinning up new layer 2 that's needed, but also easily scaling of the historical information because you can take these aggregate data and then compress it together again.
In that sense, technically, Mina is a viable solution compared to Ethereum right now. And that's why you are going to Mina.
Yeah. So Mina has this really interesting property of being able to do aggregations of aggregations. And the reason this is like really useful, even if you're working in the Ethereum land, is because this aggregation can be done up to the point where you have just a single proof of the entire Mina blockchain history, right? So imagine you want to build like a bridge between two different blockchains. For example, like Solana and Ethereum. It's not so easy because how do you prove like the entire history of Ethereum on Solana or reverse? It's very hard to do this in a succinct way. So oftentimes people take some kind of hash, a header, and then have some kind of crypto economic incentives around it. And this is why you don't see that many like bridges that are like secure. A lot of the bridges end up running on multi-sigs, these kinds of systems. And so what can happen with Mina is that you can create an aggregation over the entire history of Mina as a single ZK proof, a single aggregation. And then you can bridge that one single aggregation over to Ethereum as a state proof. And the aggregation of the Mina state contains not just the transactions, it's not just a virtual machine. It also contains the aggregation of the proof of stake itself, right? So you're also aggregating the consensus. And so it means that if you occasionally post proofs to Ethereum, you not only get the proof of the execution that has happened on Mina, you also get the proof of the consensus that has happened on Mina. And through this, you can try and do some kind of calculations to try and figure out, okay, is this extension of the proof the one has the most stake at backing it? And so you can use this to basically bridge Mina state to Ethereum and then access the result of that computation of the entire Mina blockchain history directly from Ethereum. And there's a company called Lambda Class that's working on this kind of solution at the moment. It should be coming out at some point the first half of this year, I believe, in this MVP. And so it shows how Mina can not only help hyperscale these kinds of user applications, but leveraging Mina protocol to scale these applications does not necessarily mean you lose compatibility with other ecosystems. So you can still take those ZK proofs and post it to potentially Solana in the future, post it to Cardano, or post it to all the other blockchains in the top 10 where there might be users you want to interact with.
Last time when I was talking with Brandon Case from Owen Labs, he was describing Mina also as like theoretically it's a validium. If eventually it wants to send the settlement to Ethereum, it's still possible. That is a path it can eventually take. But it is now building a system where you can actually, it's a CK native. Yeah, as you described. And from a user adoption perspective, like a lot of the people decide to go and build on Ethereum because of the user base, liquidity, and the whole size of the ecosystem. In that aspect, from a adoption perspective, are you seeing some opportunities with Mina 2 here, or like how difficult or how easy is going to be to bring new users to the Mina ecosystem?
Yeah, good question. So there's two tracks we're looking at this in parallel. So keep in mind, Zeko is this framework for creating these layer 2s for Mina. So if you want to have this kind of hyperscaling, that's what Zeko allows you to do, just for people who want a reminder. Within this, there's two kinds of use cases we're looking for. One is more Mina native use cases. So for example, we're working on a project called Lumina Dex, which is a DEX that supports private swaps between users. And this is really great because it means you don't get front run. It helps solve a lot of the MEV, which is really useful, not just for regular traders, but also for traders that have large amounts of volume they're playing with. For example, if you're buying like $100 million of NVIDIA stock, you don't necessarily want people to know you're putting the buy order until after it's executed. Otherwise, the value of NVIDIA will go up because people see your buy order. And this is the kind of MEV that plagues the Ethereum ecosystem. And so Mina supports not just this kind of aggregation of computation, it also supports private computation. It means you can place orders inside DEXs that have privacy, that people will not know your order until it's after it's executed. And so Lumina Dex is this DEX that's investigating these kinds of use cases that are not easily possible on Ethereum, but only really possible leveraging the kind of ZK and privacy that you get with Mina computation. So that's bucket number one. Bucket number two is use cases where we really want to lean into the Ethereum ecosystem or other blockchains out there that have a lot of users and liquidity. And a good example of that would be something like gaming, right? Because for gaming, you have a lot of users, you really need to scale that computation to support potentially thousands, tens of thousands of concurrent users inside the game world, which you just cannot do on Ethereum. So you need to use something like Mina to get that kind of scale. But you don't want to put your entire game just in Mina in the kind of closed box because there just aren't enough users to really monetize the game just based off the Mina users alone. Games need tens of thousands of active users to be financially viable, and Mina just does not have that many users at the moment. And so you need to have leveraging of Mina's technology while leveraging Ethereum or other crypto projects' user bases. And the way we're trying to build towards this is through use cases like PyMet, which is this framework for creating these kinds of modular applications. And the way that works essentially as an Ethereum user, you would sign with your MetaMask wallet. So you don't need to go download a wallet. You can just sign with your MetaMask wallet. And then we have an account abstraction system to submit those EVM signatures to a layer 2 that kind of enshrines this EVM signature scheme. So instead of doing this on Mina layer 1, where this would be too slow because Ethereum signatures are not really optimal for zk computation, you can have these slower computations on a layer 2 that can aggregate this without having to bog down the Mina layer 1. And so people now no longer need to go download separate wallets. So now they can play with MetaMask, whatever wallet they have, and they'll have to know it's running on Mina. And when they do financial transactions, they put, for example, they want to buy $100 worth of some in-game item. Basically, you would put those $100 inside an Ethereum smart contract. You put in the Ethereum smart contract and you say, okay, I want to buy $100 worth of this item. That smart contract holds your funds for at most maybe like a day. And what's waiting for is a proof of Mina that your purchase went through. So you make a transaction on that says, okay, I'm putting $100 to buy this item. And then you wait until the transaction on Mina happens that actually purchased those $100 worth of items. And that proof then gets bridged back to Ethereum using the state proof mechanism I mentioned earlier. So we can prove Mina state on Ethereum. And then now that smart contract can see, okay, the user placed $100 to say that they want to buy an item. And here's the proof from Mina saying that purchase was facilitated by some kind of intermediate party. And therefore execute that, send that $100 to the intermediate party and give the user the item. And so you can see how through the system, we can have users not only play from their Ethereum wallets, but also play from Ethereum funds. And so they don't have to know that this is all running a separate system. All that kind of happens behind the hood, behind the scenes. And so through this, we can allow Mina applications to really scale to the full user base of not just Ethereum, but we can build the same kind of system for other blockchains as well, right? So if we want to tap into Solana users or any other user base from the top 10 or top 100, whatever you want, Mina can support this. And so in this way, Mina is this kind of zk coprocessor, this kind of machine that theoretically multiple blockchains could leverage. And we can build these kinds of interoperable solutions between and many different kind of ecosystems so everybody can play from within the same kind of game or application state without having to natively have to know not only that Mina is being used, but that there are other players from different ecosystems playing the same kind of game as well.
So in that sense, like it's almost like this Clark's third law in the sense that like it could feel like magic that you don't need to know that you're interacting with some kind of blockchain system. It's just all those complexities are abstracted away.
Yes,
Okay.
and this is what we're working towards.
Now let's get into details of Zeko. So the technical documentation came a couple of days back, and in that you are describing Zeko as a zk-Rollup stack for blockchain developers, like OP stack for optimistic rollup in the Ethereum ecosystem. You are building zk-Rollup stack along with the DA solution and sequencer decentralization and a lot of details involved. So could you break down the core concepts of Zeko to us?
Yeah, sure. So the core concept of Zeko is we want to enable people to spin up these layer 2s themselves, right? As I mentioned, we want these use cases to be able to spin up and tear down layer 2s as needed to fit their user bases. And we also believe that for a lot of these use cases, they'll not necessarily want to sync to Mina layer 1 directly, because Mina is the kind of, just like how Ethereum plays the role of this slower, more stable network, Mina layer 1 also plays this role of this bit slower, more stable network. And so for a lot of applications, they'll either not want to run their own layer 2 or sell their applications as a layer 3 on top of a common layer 2 that's shared between many different projects. And so this is what Zeko is trying to provide, not just in terms of infrastructure, but also in terms of deployment. You say, okay, if you're a dApp developer and you want to deploy a dApp on a faster version of Mina, you don't have to run your own layer 2. You can just deploy to the kind of canonical main Zeko layer 2. And if you're a party that wants to have many different zk-Rollups for your application to scale to the user count you need, you don't need to aggregate all these directly on the Mina layer 1 and deal with all the kind of block times from there. You can have all your different app-specific layer 2s that you built synchronized directly to the kind of canonical main Zeko layer 2, which itself occasionally posts down to the Mina layer 1. And so as Zeko, we're providing not just the infrastructure for people to build on top of the system, but also we're providing a canonical deployment that people can leverage if they don't want to run their own layer 2 stack, or if they want to settle to a faster version of Mina. And so this is a bit different from what OP Stack is doing, right? Because if you have OP Stack rollup, you're basically in the current configuration building a whole bunch of disconnected layer 2s, right? So Base and Optimism and Zora, they're not directly connected with each other. They're running the same stack, but it's not like Optimism is like the layer 2 and then these other companies are building on top of that. They're all layer 2s for Ethereum directly. And this makes implementing concepts like the super chain that they talked about difficult, because these are all separate deployments working independently of each other, where you have to do an optimistic system to basically be able to go between this, unless you're really monitoring all the different chains and computing all the different chains, which is computationally difficult. And what we're setting up instead is that we'll have a kind of canonical Zeko layer 2, and we allow people to build their own layer 2s if they want, or layer 3s if they want, or just deploy to ours if they want. But it makes the composability between these different deployments that exist significantly easier. And so that's why we picked this infrastructure, and also makes it easier for us to provide stuff like liquid staking and these other kinds of mechanisms built into layer 2, so that these dApp developers don't have to worry about these kinds of, not just the deployment itself, but also the dApps that live on top of these deployments.
These dApps are also, as you describe it, like CK dApps in the context of Mina. Is there going to be also a dApp framework along with Zeko?
So the good thing about Zeko is that it's fully compatible with the Mina layer 1. To give an example of this, if you look at a zk-EVM on Ethereum, typically you can deploy the same dApp as is to Ethereum layer 1, or to one of these Ethereum layer 2 zk-EVMs. You don't need to change your dApp usually to deploy to these different layers. And so what we're creating is the same experience on Mina. So if you have a dApp that supports the Mina layer 1, you can take that dApp as is and deploy it to Zeko, and it should work just as well. The reason we did it this way, and the reason I think it's really important, is because it means that Zeko ecosystem can leverage anything else, any other developer tool that exists in Mina. So anybody who creates a framework for easily creating Mina applications, Mina dApps, indexers, wallets, all this kind of infrastructure, doesn't need to be rebuilt from scratch for Zeko. Rather, you're always just targeting the Mina system, and then you can connect your wallet, your Explorer, your framework, whatever else you've built to Mina layer 1 or to Zeko or to whatever other environments people are deploying to.
Okay, cool. I have also, in the paper, you are also describing different possibilities of data availability layers that you eventually may choose for it, or you will build your own solutions. Could you break down the basic concept of a DA layer and the path you are taking for Zeko?
Yeah. So if you remember my explanation previously of having these proofs and these aggregation of proofs and doing computation on top of the aggregation, of course, there's a question of, okay, where's the actual data for all this being stored? You get a succinct proof, a small proof of the result of the computation. Sometimes you don't care just about the result. You care about the data that went into this computation as well. And from this perspective, Mina is like a separation of concerns. Instead of Mina trying to handle both the computation system and the storage and the retrieval of these systems, rather it's split. So Mina handles just like the computation, the aggregation logic, and those kind of things. And then if you want to have the data storage and data retrieval, you have to combine it with something else. And unfortunately, there's been a lot of networks that have come and built the opposite, which is, for example, Celestia or Avail or EigenDA, which are these systems that just handle the storage, retrieval, maintenance of that data. And so you can easily pair these together in theory with Mina protocol and what they're doing. And so our goal at both Mina and Zeko is to combine with these DA solutions to allow dApps to easily have the kind of recursive proofs you get from Mina with the quick data lookup you get from one of these DA layers. Now, there is one tricky point to this, which is that when you're integrating these DA layers, there needs to be some kind of crypto proof or crypto economic proof of the data actually being stored on the DA layer. And those exist for Ethereum. So if you look up like Blockchain, these kinds of concepts from Celestia, for example, you can see how they build attestations of the Celestia state on Ethereum and how they make all that work. But all the cryptography that exists for that is obviously optimized for Ethereum and not for Mina, which has a different cryptographic scheme than Ethereum itself. And so what needs to be built is an adapter from Celestia to Mina, from Avail to Mina, from EigenDA to Mina. These kinds of adapters play the role of taking any kind of proofs of the DA layer state and then wrapping it in a way that the Mina system can understand. And those projects are ongoing. So we know the approach. Everybody's agreed on this, and we have implementations ongoing, notably for Celestia currently. And so this is just a matter of time before the connection comes into place. What we have right now is more of a federated DA layer, like a data availability committee, if you ever heard of that term. So for Zeko, we use a data availability committee for the current DA layer, and then we'll be switching over to one of these more proper DA layers once that integration is done.
So the basic difference in data availability committee, it's a bit more decent, a bit more centralized than what you call a DA layer, like what Ethereum is.
Yeah. So with a data availability committee, usually you have a set of people who are there to assure the data will be stored. So currently that committee is DC Spark, Owen Labs, Mina Foundation. So we have these three different entities storing the data and ensuring that the data is truly there. But obviously, we would like to go from a small committee to a massive committee. And this is, in a sense, one of the benefits that a project like Celestia gives you. They have an active network with many validators of that network, people running nodes, taking their TIA tokens. And by having all these many people, you not only get more assurance of the data actually being there, it also is more efficient because you can, if you're smart about it, you can shard the data to different nodes. So nobody has to sync like the full history on the machine, which might be too large for any one hard drive to store, to really help that scale. And so we're a really big fan of the work that DA layers like Avail and Celestia have done. And we definitely plan to leverage these networks as an improvement to our current stack. But our goal is, of course, to ship. And if that means we have a temporary solution for now, that's good enough, then that's what we'll do. And then move on to these other systems as a feature upgrade.
Have you looked into the data availability layer that Mina is trying to integrate? I have seen that Mina has different roadmaps, and there's for this trust minimization roadmap, there is this concept of eventually integrating data availability to the Mina layer one. Have you looked into that?
Yeah. So of course, for us, the kind of pipeline is using the data availability committee to start, then using one of these DA layers as a second step. And then there's obviously a question mark on the third step, which is, do we leverage these kinds of DA layers forever, or do we eventually build kind of a Mina native? The reason you might want to do this is because one, leveraging another stack has some kind of overhead. As I mentioned, we need this kind of adapter system as opposed to something built natively for Mina. And second, it also means that you're paying another chain for their services, right? And paying another chain for their services makes sense if you don't necessarily have the bandwidth at the time to build a solution yourself. But if you can have your own PA solution that's more fine-tuned to you, and you can internalize the cost of running this as part of running the Mina stack in general, that might be a better approach. And there's questions in the roadmap about if we build a Mina native DA layer, what does that look like? What properties of Mina can we take advantage to make it more efficient than something that's not built natively for Mina like Celestia? And what does that look like? And so those discussions are definitely ongoing. And there's other blockchains also going through the same discussion. So for example, another one that you might be familiar with is Midnight. It's building their own system called Mithril V2, which has their own kind of system for proving the availability of data. And they're doing it in a way that would not easily be doable on Celestia because they're leveraging cryptography that's native to their protocol. And I think like we'll see this not just from Mina, but other blockchains as well. They're potentially leveraging Celestia at the start, but then wondering, okay, if we want to build something that's more custom for our network, more custom for use cases, how can we do that? And for us, for Zeko right now, our focus is on getting stuff out the door as fast as we can. Actually want to have real use cases, real dApps building on our network. And so for us, the pipeline is this data availability committee to start. some kind of Celestia or Veil or some kind of DA layer as a second step. And then as other people in the community look into what a Mina native DA layer would look like, that might be a third step in the future. But right now we're focusing on getting our deployment out the door.
One of the usual questions when you look at the layer 2 roadmap of Ethereum is that they have this concept of like training wheels. And that means these systems start as not so decentralized, and eventually they, through different steps, they decentralize. And for zk-Rollups, like eventually generally for rollups, the discussion of do we need to decentralize sequencers, or is it necessary? Is that the path to decentralize these systems? And in your paper, there's also a mentioning of sequencer decentralization through auction model. When it comes to the topic of decentralization of zk-Rollups, what is the most viable path towards achieving that trust minimization part for these zk-Rollups?
Yeah, it's a good question. So for us, obviously, we will have this canonical Zeko layer 2 that we're going to try and decentralize, as mentioned in the paper, by having a decentralized sequencer set. We will also provide Mina as Zeko as an SDK that people can leverage to build their own layer 2. So if they want to build their own layer 2 with a Zeko stack and make that fully centralized that they own and they can run the single sequencer and they can upgrade in time, you're welcome to do that. If you want to go the opposite direction and use Zeko to build a fully decentralized system that has no upgrade mechanism, they can do that as well. So we're trying our best to provide that flexibility for our system, our original deployment. Obviously, we have a roadmap we're working on to decentralize the system over time. We have to ship something now to get people to be unblocked and start building use cases. So for us, for the original Zeko deployments, it'll be a federated sequencer set between us and a few different parties, as well as we'll have an upgrade mechanism to upgrade the Zeko layer 2 as these kinds of next features in our roadmap come into place. And this is not too different from something like Arbitrum, for example, which Arbitrum has a sequencer set that is basically coordinated by them. You cannot join the Arbitrum sequencer set, but they have proofs live. Like you can not just have somebody in the Arbitrum Foundation try and steal everybody's money, because the proof system for Arbitrum is actually live and operational. And so in the same way, like Zeko's proof system will be live on day one. So it's not like the Zeko team, by running the sequencers, can steal people's money, which is not the case for something like Optimism, which doesn't have fraud proofs live. So if Optimism ever gets hacked or some malicious actor comes in, like theoretically, they might be able to steal like the money from Optimism. That's not the case for Arbitrum. That's not the case for Zeko. And so it limits the vulnerability for us. In this case, we have significantly smaller training wheels, so to speak, than a lot of other layer 2s out there. But we are obviously shipping with a federated set of sequencers to start and an upgrade mechanism to start. And we'll be updating those as we go further on in our roadmap.
One question I wanted to ask you is that it's like developer adoption is a very ongoing topic of discussion in the blockchain space, because it's the industry by valuation is like really big. But if you look at the developers, according to some reports, electric capital, it's clocking around 20,000 or something. In Mina, they're using O1.js, which is similar to based on TypeScript, the way I understand it. Have you tried? What's your experience with that? And is it a more viable path towards easily attracting more developers to code, because it's something that they are really familiar with?
Yeah. So I think if you go through the Mina tutorials to try and set up yourself, it's pretty easy to set up. I think anybody that has experience with JavaScript, TypeScript, these kinds of environments, which is the majority of developers these days, can get the test example is deployed fairly easily. And you can probably go through the entire tutorial and all the deployments and all steps within a single day. So it's pretty easy kind of onboarding. And this has been the goal of O1.js, which is build a system that's built off TypeScript that a lot of developers already know, to enable them to onboard the system and build stuff really fast. And this has also been our vision as well, to try and enable people to build apps as easy as possible. And for example, for Pima, the framework we're building for easily creating these applications that work cross-chain with Ethereum and other stacks as well, all that allows users to write applications in JavaScript too. So basically the system, you can write your front end with JavaScript, you can write your back end with JavaScript, you can write the indexer in JavaScript, you can write the CK circuits in JavaScript. You make everything just one unified environment, which makes the developer experience so much easier and lowers the cost quite significantly. And JavaScript's also obviously a framework that all the AI platforms know as well. So if you use Claude or ChatGPT or other platforms, they can help you write these circuits as well. I'd say a Only one point that is remaining to be like improved on this is trying to provide deeper insights into how these ZK circuits work, which is to say, okay, imagine you build an application and you bring your ZK circuit, you deploy it to mainnet, and awesome, it works. It's super easy to write. And you decide, okay, now I want to make it a bit faster. Maybe it's running a bit too slow and the performance is not quite where I want it to be, and I want to optimize it. And these kinds of optimizations are always a really hard problem. So, for example, if you look at Ethereum, a lot of the top dApps that really need to optimize for gas, they're no longer writing smart contracts in Solidity. They're trying to like optimize on the actual byte level. How can we make these as fast as possible? And that kind of environment is not quite complete yet for Mina. So I wouldn't say like the platform is done, but as you can tell, this is like we have all the core stuff done. That's the stuff I'm talking about is okay. Once you complete the 95% of the stuff features you want, then there's like the remaining 5% to like really optimize that developer experience. But we're already at the point where these are like the next steps where there's like the small optimizations and the core of the platform is already there, already available for people to use and already pretty easy and will continue to get easier, not just through our work, but also through the fact that Zeko is this isomorphic rollup system. So it works exactly the same as Mina Layer 1. So all these implementations, all these features that come to Mina itself, all these tools that come to Mina itself to make the development experience even easier can be used as is for Zeko projects as well.
And the final part, what is the roadmap for Zeko? Is there a test net that people can interact already, or when is the main?
Yeah. So at the time of recording, we have the first MVP already live and we have it as a kind of private MVP, which is to say, if we want people to onboard onto Zeko first, we need the wallet supports, and the Explorer supports, and the bridges, and the faucets, and all these kinds of things to exist in the network to make usage for the average user who's not a developer easier. And so we have this kind of private MVP between us and a few other companies to work on these kind of core infrastructure. And then the next step after this is done, which will hopefully be sometime later this month in March, is to go to the next step of the private MVP, which is that it's no longer just these companies building a lot of the core infrastructure, but now developers that want to try it out can start building with it and build their own dApps and try porting their own dApps over and seeing how that works. If the feedback during that step is positive and everybody's really happy with it, then the next step after that would be the public testnet deployment and then mainnet after that. Obviously, once you go through multiple layers of deployment, timelines get a bit fuzzier every step of the way. But we are already starting the networks already live. These are not ideas I'm talking about that will maybe ship eventually. All these things are currently live and running on this private MVP. And we'll be working our best to try and get this in the hands of the public as soon as possible. And once we have the network actually running, then we'll also be shipping actual dApps that leverage this. Like I mentioned, the LoopNet DEX, and like I mentioned, these kinds of gaming use cases. And we have some other people interested in building stuff as well. And so we should see a steady stream of dApps coming live later this year.
Okay, fantastic. And this is the last question. From my observation, DC Spark based companies are more like infrastructure companies. You build frameworks and system for developers and platforms like Sidechain that you build for Cardano. And you have a history of not issuing any tokens because sometimes it's just a distraction. You don't really benefit from that. And Zeko will be using Mina as token for transactions, or like people can decide based on the framework to decide to deploy their own tokens or not. But from your perspective, the platform you will be deploying, will it have a native token or it will be using Mina?
Yeah, good question. So maybe it's a good time to go into my personal background so people have a context about like, the different hats I'm wearing. So DC Spark is a company I created with my co-founders a few years ago. Spark is the infrastructure and ecosystem builder company. And DC Spark has built infrastructure for a few different blockchains, including Algorand, Cardano, and a few other ones as well. And so we have quite a lot of experience building layer 2 systems inside DC Spark. We built Milkmida, which is the first layer 2 outside of Ethereum. And we've built sidechains, these kinds of things as well. And DC Spark is the core engineering team behind Zeko. So that's the background to DC Spark. Zeko is a separate entity. So Zeko is not like a part of DC Spark. DC Spark is a contributor to Zeko. Zeko also includes contributions from O1 Labs and Mina Foundation as well as Zeko has its own staff as well. And Lumina Dex is also like a separate team, and Pima is a separate team. So I just happen to have a hat in all these different entities. So it can get confusing about which hat I'm wearing at the moment. And I apologize for this. But that's like the background on all of this. Now, for Zeko itself, there will be a token in the future to decentralize the sequencer set, but the actual gas token for the network itself will just be Mina. We did this because I believe that the core value proposition of Zeko is to lower the barrier to adoption as much as we can. And the best way we can do that is by leveraging the Mina token and not introducing our own token that we force onto people. We want people to be able to easily port their data between layer 1 and layer 2 as easily as possible and connect all these systems together. And the best way to avoid friction is to leverage the Mina token. Now, of course, if somebody builds their own layer 2 with Zeko, they can introduce their own token as the gas fee if they want to. And we definitely want to support this as a use case because I'm sure a lot of people will be interested in this. But for the canonical Zeko layer 2, the one that we're going to be deploying, that will just be the Mina token as is.
Oh, fantastic. I personally am aware of your the products you have built, the things you have built for the past 6 years at least. I'm following you for at least 6 years right now. And I always wonder how are you managing to build so much and wear so many hats. But it's fantastic the way you do stuff. All the best for Zeko and looking forward to the developments that coming on to Zeko. And that's fantastic conversation with you. Thank you.
Yeah, thanks for the time. And it's the secret is that it's not just me, it's a team effort. So we have a team with many really strong engineers and we're all passionate about the technology we're building. And so that's why we have a lot of really cool projects that all have had good success in their own way. And we have a lot more in the pipeline.
Thanks for tuning in. If you are keen on getting deeper insights about Web3 tech, our newsletter, Just the Metrics, is just what you need. It's packed with valuable information and it's completely free. You can subscribe by clicking the link in the video description. It's a great way to keep up with the latest in the Web3 space straight to your inbox. And before you go, please hit that like button and don't forget to subscribe to our channel for more updates and insights. Your support is what keeps these videos coming. So see you in the next video.